the absolute value inequalities. What does it mean for the absolute value of something to be greater than or less than a number? First, let's talk about what does absolute value mean. Well, in your notes, you should see that the absolute value is the absolute value of a number is defined to be a measure of its distance from 0 on the number line. So that's why if you find the absolute value of 3 and the absolute value of -3, they're both equal to 3 because they're both a measure of distance. So absolutely, you know that you probably remember absolute value is always positive or 0, and that's why. So if I've got something like this, like you have in your notes, absolute value of x less than 3, what does that mean? Well, numbers that would satisfy this inequality would include any number that is fewer than 3 spaces away from 0. So just think about that for a moment. Think of some numbers that are fewer than 3 spaces away from 0. For example, 7. Is 7 more spaces from 3? Is 7 fewer than 3 spaces from 0 on the number line? No. So 7 is not a possible answer. Is 1 fewer than 3 spaces away from 0 on the number line? Yes. So 1 will satisfy this inequality. What other numbers are going to satisfy this inequality? You can go ahead and you can kind of color in the 1 if you want to on the number line. What about 2? 2 is fewer than 3 spaces from 0, so 2 can be included. All right? 0 can be included. -1, -2. Now, sometimes people tell me that's all, but it's not, because you want to make sure you're including, for example, 1/2, 1/4, 1/3, -1/2, -2.5. So basically, you're looking at an interval of all values between -3 and +3. Because this is a strict inequality, it does not include equals, we would use round parentheses to show that all of the solutions of this are going to fall between -3 and +3. How do I write this in an interval notation? All right, make sure you're filling this in your notes, because that's something that I'll be checking for. How do you fill this space in? Interval notation, you're going to write this as parentheses, -3, comma, +3, close parentheses. All right, and then in the notes it said I was asking for an equivalent statement. What I'm meaning there is, how can you write that as an inequality involving x? In other words, how can you write what we've graphed here using x? Well, you need to show that x is everything between -3 and +3. So one way you could write that would be with the sandwich inequality. So you can simply say that -3 is less than x less than 3. So that means the same thing. Everything between -3 and +3. Okay, our next example, we have absolute value of x greater than or equal to 2. Again, we want to think about what does it mean for the absolute value of x to be greater than a specific number. That means that its distance from 0 is more than 2. Or you're looking for numbers that are more than 2 units away from 0. Think of some examples. Pause if you need to. See if you can decide how to graph it. So you've probably determined that numbers that are more than 2 units away from 0 would include 4, 5, -3, -4, 2.5, 3.5. So you would want to draw the intervals of everything beyond 2 this way, so greater than or equal to 2. We needed the square bracket because it's got the equals with it now. And also everything less than -2. Anything out here is going to be more than 2 units away from 0. How do we write this in interval notation? We're going to say this goes from -infinity to -2. Put the square bracket with the -2, again, because of the equals in the original problem. All right, we've got a gap in our graph, so we're going to use the union symbol here, and then square bracket 2 to +infinity, parentheses. How do we write this as an inequality involving x? Well, negative infinity to negative 2 comes from here, and you can see that's everything less than or equal to negative 2. So x is less than or equal to negative 2. All right. Remember, the union symbol means it means the same thing as or. So we'll say or, and then for this piece, x is greater than or equal to 2. So the discussion that we've just gone through showing how the absolute value of x being greater than or less than a number creates a certain graph, and then the interval notation and the inequality version of those graphs gives us the rules that we need in order to solve absolute value inequalities. You'll find the rules explicitly stated at the bottom of your note, the same page of notes. We've got, it's in terms of k. Sometimes that's confusing for people. K is just a constant. But you'll see the rule at the bottom of the page that we were just working from. Those rules are essential to being able to solve absolute value inequalities. And hopefully you'll understand why we have those rules based on what we just talked about. So let's go ahead and look at example 5. So example 5, part A, we're going to solve absolute value of 3x plus 2 is less than 7. Because this is the absolute value less than a number, we'll go to the sandwich inequality. The rule says that we're going to take the opposite of the constant that we have here. So we're going to take a negative 7, set that less than the inside of the absolute value. So we'll set that less than 3x plus 2. And then that's going to be less than the constant, 7. And then we can solve that. So just like with any sandwich inequality, you're going to want to get your x by itself in the middle. So you can see that you want to start by subtracting 2 on all 3 sides. I get negative 9, less than 3x, less than 5. All right, and again, if you look at it, you can see you're going to divide everything by 3. So divide all 3 sides by 3. We've got negative 3 is less than x, less than 5/3. The directions ask us to graph the solution set. It does not specifically say to use interval notation, but we're going to do that anyway just to make sure we're comfortable with it. So let's go ahead and graph this. Where is 5/3 on your graph? 3 goes into 5 not quite 2 times, so it's not quite 2. So it's going to be just a little bit before you get to 2. You're going to shade everything from, so x is telling you where your solutions are. They're everything between negative 3 and 5/3. And they do not have equal signs with them. They're just strict inequalities. So what symbols will we be using at our endpoints? We'll be using open circles or the round parentheses. So we're going to go negative 3, parentheses, shade everything about almost up to the 3, not quite there, and shade all that in. Okay, that's our graph. For our interval notation, we would have parentheses, negative 3, comma, 5/3, and then close your parentheses. This is the interval notation. Example 5, part B, we want to solve negative 2 times the absolute value of 4 minus x less than or equal to negative 4. All right, before we can do anything, we need to isolate that absolute value first. In order to isolate our absolute value, we need to break this apart. So we want to divide both sides by this negative 2. All right, make sure that you remember, when you divide by a negative, you flip your inequality symbol. So we have the absolute value of 4 minus x greater than or equal to positive 2. And now we can set up our two cases. Because this is a greater than, this is going to be an or statement. If you think you're going to have trouble remembering that, you can think of the silly little word greater. Okay, greater. So if it's a greater than absolute value inequality, you'll use the or statement to separate the two inequalities. We're going to do 4 minus x greater than or equal to 2. Or, and again, go back to the rule at the bottom of the last page where we were discussing the inequality, absolute value inequalities. That's where the rule is. It says that you're going to do the inside of the absolute value greater than or equal to the number that you have here, or the inside needs to be less than or equal to the opposite of your constant. So 4 minus x less than or equal to negative 2. Solving for x on the left, we're going to subtract 4 on both sides. We have negative x is greater than or equal to negative 2. Divide both sides by negative 1, and you've got positive x is less than or equal to positive 2. For my second inequality, I want, again, keep x on the left side, so let's subtract 4 on both sides. That gives us negative x less than or equal to negative 6. Now divide both sides by negative 1, and you've got x is greater than or equal to positive 6. All right, so let's see what this looks like. On the number line, I'm going to pause it just to save my battery real quick. So we're going to graph x is less than or equal to 2, or x is greater than or equal to 6. So less than or equal to 2 is going to put you back here with a square bracket or the closed circle. X greater than or equal to 6 puts me over here with a square bracket shading to the right. My integral notation will be, think about what you think the integral notation should be. Pause if necessary, but integral notation is going to be negative infinity to 2 with a square bracket. Union, because you've got a gap, so we put the union symbol, and then you can do square bracket, and I apologize, I'm running out of space, square bracket 6, comma, infinity, parentheses. So parentheses negative infinity to 2, union, square bracket 6, comma, infinity with parentheses. There's a better view. Example 5, part C, we're asked to solve absolute value 7x minus 9 greater than or equal to negative 3. Okay, now before I start trying to set this up, let's take a moment and think about what this is saying. What do we know about absolute value? If you take the absolute value of any number, you know it's a measure of distance. So will it ever be negative? All right, I'm going to ask you to pause the video, give this some thought, think about what you know about positives and negatives, greater thans and less thans, and just give it a moment. So, because absolute value is always positive or 0, we've got a positive here greater than or equal to a negative here. Okay? That's either always true or always false. Which one is it? A positive is always greater than a negative number, so the answer to this is going to be all real numbers. Or you could say infinite solutions. If you don't notice that, you can go through the steps, but then when you go to graph it, if you're graphing it correctly, you should end up with the entire number line shaded. So you'll have other problems similar to that that might be a little bit tricky. And if you're running into some major issues when you're trying to solve these absolute value inequalities, you might need to kind of take a step back and think about what they really mean. And that might shed some light on why you're having difficulty possibly with it. Okay, I believe that's it for that section. So yeah, this finishes chapter 1. Chapter 1 is now complete. So make sure that you bring good questions to class, and we will discuss this further in class.